Our next session will be about what SQL Server DBAs need to know about Docker containers. Our speaker is Edwin Sarmiento. He's a Microsoft certified master, a former MVP, a Microsoft trainer. He's based in Canada, and his book just came out. It's the SQL Server DBA's Guide to Docker Containers. So, good morning, Sir Edwin.
Good evening. I'm still trying to figure out if I'm supposed to say good morning or good evening. Just
Yeah.
just to give you guys a little bit of context, we just got back home here in Canada this past week. Well, 2 weekends ago. We were stuck in the Philippines for like 4 months, 4 long months to be stuck in a very cramped condo unit because of this whole pandemic thing. And it's interesting how I can see people. It's it gives you a totally different perspective. Being stuck, being stranded, and sometimes we don't really pay attention to what people are going through because being in a country like Singapore, I used to live in Singapore. I kind of miss the East Coast Park. We used to live at a flat a couple of kilometers away from the East Coast Park. We could easily go there, and it is a little bit nostalgic when you think about it, because we don't really pay attention to what's going on around the world because we're comfortable. We can see what's going on within us, but not really having a first-hand experience of what is going on around the world and how people are suffering. In fact, I was just browsing Facebook. I rarely do this. I was just browsing Facebook, and a former colleague of mine, his eldest sister, died of the infection. And it's quite sad that things are happening all around the world, but it doesn't mean that we ignore other people's sufferings. And so I want you to take, while I'm figuring out how this whole thing works, I want you to take some time today and think about what's the best thing that ever happened to you today. Because sometimes we're so overwhelmed with the bad news, we tend to forget that there are a lot of great things that are happening all around us. I'm just thankful for the fact that I'm home. I'm just thankful for the fact that I've got like fast internet. Back in the Philippines, I was like working with 3 point something Mbps every day. So it was one of the best things that happened to me, because at least I was able to finish my book while in lockdown. Anyway, I hope you can see my screen. If you can, please let me know. If not, I'll try to work around it. My topic for today is something that I have been doing since late 2018, I think. I can't keep track of time at this point, but it's something that I have been talking about since late 2018, and early 2019 was the time when I was approached by a publisher to start writing about it. It's all about Docker containers, and a lot of data professionals, specifically database administrators, are struggling to really have a hold or have a grasp of this. Give me a quick second while I switch my my sharing option. I want to share my entire screen. There. Hopefully you can see my screen now. Okay. My name is Edwin. I was a Microsoft MVP for 12 years. My key area of expertise is on SQL Server high availability and disaster recovery. You might be thinking, what on earth am I doing with Docker containers? When you do think about it, the landscape for IT is constantly changing. Back then, we were all just thinking about on-premises. Now we're talking about the cloud. Back then, we were talking about physical machines. Now we're talking about containers. Back then, we were talking about thick clients. Now we're talking about APIs and the cloud, and how IT is constantly, and technology is constantly changing. And my goal for this topic is to, number one, introduce you to a world that some people in the industry have been very much familiar with. The developers are very much ahead of what's going on. Unfortunately, DBAs are way behind. If you have questions during the presentation, feel free to type them in the chat window. Got my website, my email. I'm on Twitter, on LinkedIn as well, although my website's down. I need to call my hosting provider. I want to start off with a premise. This has been a buzzword for the past, 3 or 4 years now? And I want to demystify this word. What is DevOps? I'm taking this from an AWS definition. It's the combination of cultural philosophies, principles, practices, and tools. I've highlighted these keywords because a lot of people think that DevOps is all about the tools. No, it's not. In fact, I remember it's almost 15 years ago when I was working as a data center engineer for Fujitsu in Singapore. We have been doing DevOps even before it was even called DevOps. It's how we built our team. In fact, every time a new engineer is getting hired, we look for qualities. We look for skill sets. We look for cultural fit. We want somebody who knows how to automate things, knows how to think of moving processes and making sure the processes are efficient, because our goal is to deliver services at a high pace, not just for the sake of doing it at a very fast pace, but also we want to make sure that we're delivering services efficiently. It's evolving and improving products at a faster pace than organizations using traditional software development process and infrastructures have done before. In fact, I remember the times when I was working as a data center engineer in Singapore, I barely touched the keyboard. I'm barely in front of my computer. I spend a lot of time in whiteboards or with pen and paper, writing down and creating workflows, because we want to make sure that everything that we do can be, number one, automated, and number two, can be streamlined, so that if a new process is introduced or a new product is introduced, we can tell the customer, we can do this efficiently, we can do this fast, and we can lower down your cost, to a point where we actually do our DR exercises every quarter. How many organizations do you know nowadays are actually testing their DR processes and see if it works? We've been doing it 15 years ago. We just didn't call it DevOps. And it's a cycle, it's a process. If we find inefficiencies in the process, we go back to the drawing board and fix it. This is what DevOps really is. It's combining cultural philosophies, principles, practices, and tools. The buzzword around DevOps for the past couple of years has always focused on the tools. It's never about the tools. It's the combination of, again, cultural fit, principles, practices, and tools. It can't be just about you. It has to be the entire organization. In fact, we brag about the fact that even though we're a very small team in the whole Fujitsu organization, we were the most profitable business unit for 3 consecutive years because of this. And this is huge, right? Now, you might be wondering, why do we need a new platform, a new technology, or a new tool? Let's go back to the real reason why technology is getting introduced on a regular basis. Think back to the days of physical machines. This was the day, or these were the days when, if I need to deploy an application, whether it's SQL Server or a web app or a middle tier or what have you, I would have to call my hardware vendor. I would give them maybe a purchase order of a Dell, an HP, or a Lenovo server. What's ironic is this. The ironic thing about this is the fact that, we as data professionals, we who are supposed to know stuff and base stuff off of data, because we're data professionals, right? We make guesses. You're right, guesses. What do I mean by that? Well, we don't know the workload, we don't know the baseline, and so we call up Lenovo or HP or Dell and tell, give me the fastest server that you have. The fastest, X number of cores, X number of memory, X number of hard disk, and this and that, and we don't know. Again, which is quite ironic. We should have known, but every time you deploy a new application, you're kind of guessing. You're guessing about the compute capacity. You're guessing about the storage capacity because you don't know, right? If this was a migration or an upgrade, at least you have some sort of a performance baseline that hopefully you've monitored, you've taken. And this challenge has become more of a financial challenge because, well, you're buying a very expensive hardware and you're not really maximizing it. 10, 20 years ago, you've seen servers that are operating at 20% capacity. Your CFOs and your CIOs and your CTOs don't like that. Because at the end of the day, an idle asset, as far as accounting is concerned, is a liability. Hence, virtualizations came in. This is where you're going to buy those very expensive beefy hardwares, those Cisco UCS machines, and you will stack it up with as many VMs as you possibly can. Not only are you saving money on purchasing hardware, you're also saving money as far as licensing is concerned. I mean, think about that for a second. I can stack multiple SQL Server VMs on a physical host and be able to run it and just buy one license, well, not one, but number of core-based licenses for an entire physical machine. So just one physical machine, I can run 20 SQL Server VMs. I only buy one SQL Server Enterprise Edition license multiplied by the number of CPU cores, and I can run an infinite number of VMs. Well, I don't want to say infinite, but that's what a lot of customers are doing. Hence, we have solved what the physical machine era has presented as a challenge and into the virtual machines. But here's the thing, though. Even in the days of virtual machines, I remember the days of Microsoft Virtual Server. I remember the days of Connectix Virtual PC. Even with virtual machines, there are still challenges. For one, we spend more time patching operating systems. We spend more time managing operating systems, yet we're not in the business of managing operating systems. What do I mean by that? Well, you do audits. You want to make sure that they're licensed. You do security patching. You do hardening. You do monitoring. You're doing so many things that have nothing to do with the business. And that's why IT is always perceived as a cost center. Guess what happens to cost centers in pandemics like this? They are the very first ones to go. Every cost center, because they want to cut costs. Businesses want to cut costs. And hence, we come into this stage of containers and introducing containers. But what problem does it solve? On top of, well, I don't have to worry about managing operating systems, right? Imagine the amount of storage space needed in order for you to deploy multiple virtual machines. I don't have to deal with that anymore. I mean, I could reduce the storage capacity needed for my applications if I deploy containers. But really, what problem do containers solve? It's really that developer response. Hey, it worked on my laptop. I can't count the number of times I would get into a troubleshooting exercise with a client or a customer. We would fix a performance issue or a functionality problem, and the common response has always been, well, it worked in my laptop. Containers solve this specific issue or this specific challenge to reliably run software when moved from one computing environment to another. I mean, virtualization can partially do this, but when you think about it, if I'm running from a physical machine to a virtual machine, I'm going to do a P2V. If I'm running from virtual machine to another virtual machine, I'll still have to think about, wait, is that destination running Citrix? Is it running Hyper-V? Is it running VMware? I still have to worry about that. With containers, you could do what I call a lift and shift. I could take an application wrapped in a container, developed, tested, run, what have you from a developer machine and put it on any container platform, whether it's on premises, on the cloud, on a hosted environment, and it will just work as fine so long as the container host shares the underlying kernel. And that's what I'm going to talk about today, the whole gist of the technology behind containers. For some of you, it might appear a little bit confusing. So what's the difference between virtualization and containers? I want to show this graphic. Let's look at a hypervisor architecture. In a hypervisor architecture, you have your physical machine or hardware. You're going to install a thin layer of abstraction called the hypervisor. Whether it's Hyper-V, whether it's VMware, whether it's Citrix, that thin layer of abstraction presents the hardware as a virtual resource. And then you can create your virtual machine. You can assign as many virtual CPUs, virtual RAM, assign virtual storage to the virtual machine, and then you gotta install an operating system. If you were to ask me, I would rather not have an operating system. I would just have an app. But operating systems are necessary evil. They needed, well, we all need operating systems in order to run apps. I wish there would come a time when apps could run without operating systems. And quite frankly, though, when you start looking at a hypervisor architecture, every time you create a virtual machine, you would need a copy of the operating system. Now think about that for a second. Imagine you're running 4 virtual machines, each one running Windows Server 2016 or Windows Server 2019, or even Windows Server 2008, because people are still running that in the wild. How many copies of the Windows operating system are you actually running? In this case, this graphic, you got 4, which means you need to have enough resources to run 4 copies of the operating system. I did mention earlier, you need to patch it, you need to maintain it, you need to secure it, you need to update it, you need to monitor it. One of my clients actually have a spreadsheet of the number of hours it would take to manage a cluster node whenever they're deploying an availability group, and they would then submit that to HR. If they add another node, they would then need, depending on the number of hours, they would then need an additional staff, an operations engineer, in order for them to deploy this particular infrastructure. That's the hypervisor architecture, and that's virtualization. In contrast with containers, say you got your hardware and then you have your operating system. Look at that layer and compare that with a hypervisor architecture. In a container architecture, you only have a single copy of the operating system, just one. Just one. And then you can have a container as an abstraction. A container just presents the operating system. It virtualizes the operating system so that you can run applications on top of it. Besides, like I said, operating systems are a necessary evil. I would want to see that day when we can run apps without operating systems. But in this case, well, we still need it, but you don't really need a full-blown operating system. You just need some of the functionalities of the operating system in order to make the app work. And so you can have as many containers as you possibly can, and not have to worry about managing operating systems. It's one of the reasons why developers, like I said in the beginning of the presentation, developers are way ahead of us DBAs, us data professionals, when it comes to DevOps and containers and the whole practice. It's because of the fact that they don't need to know the underlying operating system. They just need to know how the app works. So this minimizes the need to maintain operating systems. It minimizes the need, well, if I was a CFO, I would just think about, well, it minimizes the need to license operating systems. It minimizes the need to support it, to maintain it, and moving forward, it minimizes overall costs. Containers are a Linux concept, in fact, which is quite interesting. You might have heard of the company called Docker. Docker is to containers as Red Hat is to Linux, as VMware is to virtualization. they've pioneered and made container technology available to the masses. But when you really do think about it, it's not a new technology. It's been around since the late 70s, which is interesting. In the Unix world, the concept of virtualizing the operating system has existed as early as the late 70s. It's just the fact that, yeah, it's a cool technology, but we can't use it, so it's useless. It was only up until the early 2000s that somebody came up with the idea of, let's capitalize this technology to solve a business problem. It's also the reason why, well, all of the demos that I'm going to show you today are going to focus on Linux. And it's also one of the reasons why you would see Microsoft investing heavily in the Linux operating system. Azure is running more Linux OSs than you could ever think of. And this is where Microsoft is headed. So you got to wrap your head around the fact that as a SQL Server DBA, I need to learn Linux whether I like it or not. It is where Microsoft is headed. Trying to virtualize the Linux operating system kernel, unlike virtualization where you're virtualizing the hardware. Containers virtualize the operating system kernel. Because you're running multiple apps, or in this case, multiple containers with apps inside a single operating system, you're actually sharing the host's kernel. Think of creating virtual splices of the operating system and presenting it to the kernel, or rather to the container. It uses the kernel's ability to group processes for resource control. You can think of containers as individual processes, each one siloed so that whatever happens to the container does not affect the other containers. And they feel like lightweight VMs. That's why people think they're VMs, but no, they're not virtual machines. Some people would call them virtualization 2.0. But again, think of what virtualization is. It's virtualizing the physical hardware. Containers, it's abstracting the operating system. Well, you can still think of it as virtualization, but you're not virtualizing the physical machine or the hardware resource. You're virtualizing the operating system. I want to switch gears a bit because I've given you a high-level overview of what they are and what you can use it for. Let's look at how Docker runs containers. Docker, like I said, is kind of like the Red Hat of Linux or the VMware of virtualization. It is the company that pioneered or made container technology available to the masses. So it's important for you to understand how it works because, with the different container apps that are available that you can leverage, in our case, we will start calling SQL Server as an app. Well, I know it is the server that runs databases and with relational database, but from the point of view of container technology, it is an app. So how does Docker run containers? You have your Docker client, and then you have your Docker daemon. Daemon is just a Linux word for service, just like in Windows. When you run a command from the client, the daemon responds. Let's say Docker run. I want to run a container. Here's what the Docker daemon would do. First, it will search within itself. Is there a copy of the image that represents this container? It will first search its internal repository, or in this case, the local hard drive. If there is no image associated with the container that the client wants to run, it will reach out to a container registry. By default, Docker's container registry is the Docker Hub. Microsoft used to host all of its containers on Docker Hub. Now they have their own. It's called the Microsoft Container Registry. Think of the Docker Hub as the App Store for iPhone or the Play Store for Google. The Docker daemon would reach out and it will start pulling the image required to run that specific container that the client wants to run. Stores that file in the local repository and then runs a container based on that image. Now you can run one or many instances of that container from the same image. And the beauty of this is you only pull or you only download the image once, and you can run as many as you want, of course, depending on the hardware resources available on your system. Let's have a look at this in action. I want to switch gears a bit, and I want to introduce you to a Linux environment. Hope you can see my screen. This is PuTTY. I've been using PuTTY ever since, I don't know, early 2000s when I started working on Unix and Linux. You're going to see me work on the terminal, the command line environment. And again, whether you're a SQL Server DBA or a Windows admin taking care of SQL Server databases, this is something that you need to be familiar with. If you have been writing scripts and automating stuff, this should be very familiar to you. What I have in here is a Linux environment. Of course, I have to type properly. I'm running a CentOS Linux host, and I've installed Docker on the Linux host. This Linux host will now function as a Docker host, meaning I could run Docker containers on top of this Linux host. And I can explore this using Docker commands. But because I'm running Linux, I want to introduce you to a very simple concept in Linux called least privilege. Even though I'm logged in as me, this is my account, I'm restricted to running non-administrative commands. Like for instance, hostname is a non-administrative command. IPADDR to display IP addresses is a non-administrative command. But when I start running Docker commands, because it requires administrative privileges, I need to prefix the command with sudo. So sudo docker info, I want to display the information of my Docker host. It will prompt me for the password of my account. My account is actually a local administrator, but again, because of the default behavior of least privilege, it will not run any administrative command without prefixing it with sudo. And you would see the properties of my my Docker host. I'm running CentOS 7. And the reason I'm running this is because, well, this is the community version of Red Hat Enterprise Linux. So if you're working with CentOS, you could easily work with Red Hat, provided that you pay for support and licensing and you pay big money to Red Hat. This is connected to the internet. Ping, let's say. Why is that? Because I will start running a container, very simple container, and explain how Docker runs containers. I have a very simple command here. Hello world. Interesting because every single programming language has hello world. And just to demonstrate that I won't be able to run this because it requires administrative privileges. Here you could see me running the docker run command, and it's telling me permission denied. So I'm going to prefix that command with sudo. And this is where it explains visually what I just talked about a few minutes ago, how Docker runs containers. First, I ran a command, docker run hello world. Hello world is the name of the image that I want to run. Because this image, this is a fresh install by the way, is not locally available, it searched its own local repository, it's not there. It went out to Docker Hub and started pulling the hello world image from the Docker Hub. Pulled. You might be thinking, what is this? Well, it's a very small image. It says pull complete. Downloaded newer image for hello world latest. So what it did was it pulled the image from the Docker Hub, stored it in the local repository, ran the container. the container functions, in this case, the hello world container I'm referring to, has one function. The function of the hello world container is to display this message. Once the container has done what it's supposed to do and nothing else needs to be done, it exits, it terminates. In fact, sudo docker ps. Docker ps is the command to display all the running containers. You won't see anything. Why? Because the container has already completed its task. There's nothing else to do. Therefore, it exits. In fact, if I pass -a, which means display all containers running or terminated, you would see that I had a hello world image ran 2 minutes ago, or created 2 minutes ago, but exited about a minute ago, and its name is Ferment Blackburn. Interesting, because Docker will automatically generate fancy names based on an algorithm that a cool developer did. But the idea behind this is, because a container ran and there's nothing else in the container to continue running, it will terminate, exit, and it's still going to be there. You could think of this as a virtual machine that was started, did its job, and then shut down. The virtual machine is still there, but it's no longer running. You can run the same hello world image if you want, using this existing image. No need to create a new one. You got your container ID, you got your image name command. This was the command inside a container that ran. And then you have the created property, the status, and then the name. You're also wondering, what's this port? Well, think of containers just like VMs. If you want to access what's inside a container, you need to open up port numbers. You need to open up the container to your network in order to access the application inside those containers. Remember what I mentioned earlier about the Docker daemon pulling the image from the Docker Hub and storing it in its local repository. You can see I've got the hello world image, and it's 13.3 kilobytes. What I did was I pulled some of the images from I already pulled some of the images from the Microsoft container repository, because I don't want to be waiting a couple of minutes just to pull or download a 1.61 gig image, right? I think I'm working on a different image here. I think I'll switch back to here. Sudo docker run hello world. And it's going to do the exact same thing, where it's going to pull that image, store that image in the local repository, and then run the Docker container. And it's the exact same thing. Sudo docker images. Yep, this is the one that's pretty clean. So imagine that it's pretty small. Okay, if I run the exact same command earlier, you don't see the message where it says unable to find the image locally, and then pulled it, nothing there. In fact, it took less than a second to run the container, perform its job, and let the container and the app inside the container do what it's supposed to do. Okay. There are a couple of things that you have to consider. Like, for instance, if I wanted to run, or if I wanted to search, for instance, images that I could use. What you're seeing here is the Docker Hub landing page for the SQL Server on Linux Docker containers. Okay, these are the different images that are available for SQL Server on Linux. There's the 2017 latest, the 2019 latest, the ones with cumulative updates, and so on and so forth. And it showcases how we can use these images. So let's use that. Let's try, because I already have in this case, I have just one image. Okay, let's do exactly that. I'm going to run a SQL Server, not Windows, but a Linux. And I want to explain this command. Docker run -e. Well, I need to prefix this with sudo. -e is an environment variable. It's what you pass on to SQL Server on Linux as part of the installation process. Pretty much self-explanatory. You want to accept the EULA, even though we don't really read any of the words and terms inside the EULA. As a password, is this? Yeah, you can be more fancy about your complex passwords, but keep in mind that SQL Server on Linux does require a complex password when you're installing. -p is the port number. I want to access SQL Server on Linux. Okay, I want to access SQL Server on Linux in a container running in a Linux Docker host, and I want to use the standard port numbers. I want to expose port 1433 on the container and expose that on the host. I want to name it Linux SQL Linux Con 01 because I don't want Docker to name my container. It could be fancy, but I won't be able to find exactly which container it is. -d is detached. I don't want to be connecting interactively to the container. Besides, SQL Server, if I can run SQL Server without a UI on Windows Server Core, I would. It prevents people from logging in, doing nasty stuff, and rebooting machines. And that's why we have the -d. We want it to run as a detached container. -h, I want to use this as a host name. Better yet, while I'm explaining this, might as well run it. This is the host name because some developers like hard coding computer names and instance names in their code. So I want to make sure that whatever app they're running on and whatever code that they have that hard codes host names, I can catch it. And instead of using the latest specific version of the SQL Server on Linux, I'm going to use this. I don't even know what version this is, but I'm going to use this one. Okay, Microsoft. This is the image that I want to run. Let's run this in this environment. Okay, and exactly what happened earlier, it didn't see the SQL Server, MS SQL-server-linux image in the local repository, went out to Docker Hub, searched for that image, whether the image is in Docker Hub or on Microsoft Container Registry, and got redirected there, pulled it, and you could see all of these layers being pulled. The images are broken down into multiple pieces, just like Lego pieces, and then they're meshed together, grouped together to build a full-blown image. And you can see there downloaded newer image for Microsoft SQL Server on Linux. We could check Docker PS that this is already running. See this? This is the container ID. This is my image name. Like I said, I don't really know what version. Well, I know it's SQL Server 2017, but I don't know which CU is in there. I don't know if it's RTM. I don't know. We would have to check. The command running inside a container is this. It's inside the opt msql bin SQL SERVR. If you're familiar with that, it's the exact executable that we see in SQL Server on Windows. It was created 21 seconds ago. It is up for 20 seconds. And it is mapped to 1433 TCP, and the container name is called SQL-Linux Con 01. Let's connect to this. IPADDR. I will connect to this using the IP address of the host. And I'll open up SQL Server Management Studio and connect. And we could check and validate. Select at server name. Select at version, because that's what we want to know. See, the host name is there. And it is running SQL Server 2017 RTM plus CU13, which is kind of interesting. And if you look at the operating system, interesting. It's running Ubuntu 16.04.5. When in fact I'm running CentOS Linux. Remember what we talked about containers earlier? Containers abstract or virtualize the operating system kernel. Keep in mind, even though Red Hat is based on is a different distribution than Ubuntu, they still share the same Linux kernel operating system. So the only thing that the container would have will be the difference in the underlying kernel operating system, which means I can run the exact same SQL Server on Ubuntu Linux container on a CentOS host, on a Red Hat Enterprise Linux host, on an Ubuntu host, or on a SUSE Enterprise Linux host. Of course, so long as those platforms are supported by Microsoft, you should be able to run them. And this is, again, one of those challenges that I mentioned earlier. This is one of the big reasons why containers have become a thing. I can have a developer working on Ubuntu on his or her laptop, create a container, deploy it on AWS, on Azure, on GCP, and it would just work. This is the beauty of containers. Unlike, well, worked on my laptop, but it couldn't run on production. So think of it this way. I could have a developer running an Apple MacBook Pro with a Docker container running a SQL Server 2017 on Ubuntu Linux, deploying it on on-premises CentOS Docker host or on Azure as a container, and it will still work. That is the power of containers. Now let's go back to the presentation and see what else is in here. We've seen how Docker runs containers. We've seen the architecture behind it, where you have your Docker daemon, which is your Docker host. We've seen Docker Hub, which is the repository of images. You've seen a Docker client, which is basically a command line interface that communicates with the Docker host. You've seen how images are being pulled and how images can now be run. In fact, why don't I go back to the environment and kill the image. Sudo docker ps. The image is still running, right? Want to kill it and remove it. Docker stop. And the good thing about this is because I provided a meaningful name, I can stop and remove it. Okay, this is me stopping and deleting a container. What if I want to run another instance of that image as a container? Remember how long it took for the image to be pulled down, to be started? Now think of it this way. How long does it take for you to provision a SQL Server database today without containers? Think about that for a second. It depends. If you're deploying on a physical machine, it might take forever because you have to submit a purchase order. You have to get your purchasing department, reach out to the vendor. The vendor has to deliver the physical machine. The vendor has to rack and stack the physical machine, connect the cables, connect the wires, and then you install SQL Server, and then you create a database. How long does that usually take? Yes, I know what you're thinking. In a container, boom, done. Yes, you might be wondering, wait, what does that mean? I just deployed SQL Server in less than half a second. And it's a new container. If you recall, it now has a different container ID because I just deleted the old container and removed it in the Docker host. And now this is an entirely new SQL Server instance. Let's have a look at it. Yep. Same image, therefore same version, same host name, but totally different container. And that's how quick it is. And like I said, the developers are now starting to take over the job of DBAs. Well, part of the job of the DBAs because, well, they know how to deal with containers. They can just pull a SQL Server on container image, run it on their machine, create database, run scripts, deploy it, wrap it up in their deployment workflow. They don't need DBAs. And that's why we need to make sure that we're catching up on this, because sooner or later, the developers will start taking over most of the tasks of the DBA, even though they don't have any clue about what data is and how to take care of data. Okay, again, you've seen the power. It's as easy as want to deploy, run a command, boom, done in less than half a second. What took time was the amount of time it took to pull the image initially, but once the image is already on your local repository, quick and fast. Okay. I mentioned images and containers, and I may have accidentally interchanged these two words, but what are they really? Let's differentiate an image versus a container. An image is a read-only template for creating application containers. Think of an image as a virtual machine golden image. Let's say I want to deploy a Windows Server 2016 with an application. I would install everything that I need inside that image and then mark it as read-only. If I want to deploy a new virtual machine, I will just use that image as a starting point. The image is still read-only. Any changes made to the virtual machine is written on a different file system. Think of images like, I forgot what the exact term is for Hyper-V and VMware, but think of this as the read, because I'm using it in my environment, as the differencing disk in Hyper-V. Okay? Containers, on the other hand, are a runtime instance of an image. The container will always be based on an image, but because an image is a read-only template, containers can't write on to the read-only template. So here's how it works. You can think of an image as a set of file system layers. Each file system layer contains a delta, a change, and that change could be an operating system dependent file like a library, or it could contain an application file like your SQL Server binaries, or it could contain application dependent files like a cumulative update. These file system layers function like Lego pieces. Think about that for a second. Lego piece. I could use different Lego pieces and come up with something. Could be, an action figure, maybe Lego Ninjago or what have you. Put them together and I can come up with something. And then I can use the exact same piece to create a totally different thing. This is the reason why the images can be compact, because when you think about it, every SQL Server image starts from an RTM image. A CU21 image, SQL Server on Linux with CU21, 2017 with CU21, will still have the RTM image. So all that a new image would do is reference an existing image, like the SQL Server on Linux RTM image, and then put something on top of it. like the CU21 application update. And all that Docker would do is to read both of those file system layers to come up with an image. How a file system layer is built is seen when you start pulling those images from the container registry. You've seen this image earlier, you've seen the messages. Every single GUID value here is actually a file system layer. And how Docker deals with this is, well, it will first look at the base layer, and then it would find the next layer on top of it and builds those layers, stacking them one on top of the other. Once it knows those different layers, it will read the metadata, and then it will build an image based on these file system layers, based on the metadata. The metadata could define how SQL Server 2017 with CU21 works, and then locks that image. That image becomes the reference point for every container that you create or you run. Okay? A container, on the other hand, because like I said, your images are read-only, a container is simply a read-write layer sitting on top of the read-only layer. This is one of the reasons why it's very efficient as far as storage is concerned. If I'm creating a container, I'm only creating that thin read-write layer. I'm only going to create that thin read-write layer for every container that I create without changing the underlying base image. So you can run many SQL Server on container instances and only have that read-write layer representing it. If you delete a container, it doesn't affect the image. Okay? And this ties into creating those images. What if I don't need, or what if I don't like the ones that are provided from Microsoft Container Registry? Well, you have the option to create your own image. Creating a custom image is simply giving you the power to create images that would meet your business requirements. For instance, if you don't like the way that Microsoft is releasing cumulative updates because you need to go through a series of tests, you might want to create a base image that is running maybe CU13, because that's that's what your applications use and that's what you've tested. If you let Microsoft decide they're going to push, the latest cumulative updates, what if, you haven't tested for the latest cumulative updates? You run the risk of maybe some breaking changes. And this is where the Docker file comes in. The Docker file is kind of like a menu, a recipe. A Docker file simply contains commands that you use to build your own custom image. And it could be any image. I'm only using SQL Server because, well, this whole presentation is all about SQL Server, right? It could be anything. You can create your own web app. You can create your own custom application. You can create anything so long as you have the Docker file. Let me break down the contents of a Docker file. And like I said, a Docker file is simply a text document, a recipe for building a custom image. It contains all the commands a user could run on the command line to create a custom image, but you automate the whole process. Think of a Docker file as infrastructure as code. Why infrastructure? Well, for one, in a virtual machine, you're building an entire infrastructure, standalone machine with SQL Server, with all the configuration settings, and it's in there. So you can think of a Docker file as infrastructure as code. I want to explain the contents of a Docker file. The Docker file starts with the base operating system. And I'm not talking about a full-blown operating system. I'm simply talking about the difference between the Docker host's operating system and the target container's operating system. In this case, CentOS. Not big of a deal because my underlying Docker host is running in CentOS 7, and I'm using CentOS for my base operating system for this particular image. The label is just metadata for you to tell developers, users, what this image is all about. I'm running Microsoft MS SQL-Server-Linux version 14. It's running on CentOS 7.6.1810. And this is the guy that you need to call or email if you have any issues with this image. Really, nothing much as far as metadata is concerned. The next command is simply, well, I've got two commands here. One is the run command. I want to run this particular command, which is curl, which is pulling down the repo, the definition for where I can download the SQL Server 2017 installation packages. The second run command is installing SQL Server, passing the -y parameter, which means any question, I'll answer with y. Even, did you read the EULA? Yes, well, not really. This automates a process of pulling down the installation package for SQL Server 2017 and installing it automatically. I will define the environment variable. This is the starting point for whatever command I would run after this. In this case, it's opt ms equal bin. Think of this path as your C program files, Microsoft SQL Server, and so on and so forth. Then I'll create a directory using mkdir. I'll create this directory called var opt ms equal data. And then I would give the SQL Server or the MS SQL user. By default, the MS SQL user is created when you install SQL Server, and I would grant this the group and user ownership for the var opt ms SQL and the etc password directory, because I want to store my secrets, my passwords in this directory. Expose is simply telling whoever's going to use this image, look, the application that's going to run on this container based on this image will be listening on port 1433. Command SQL Server. This is kind of like your SQL Server executable. Okay, you save this as a text file, run and build, and you now have your custom SQL Server on Linux image. Okay, to run it, you use just the docker build command. Now let's do this real quick. And I'm going to switch gears to this one because I don't want to pull those information. I'm going to create a new directory. First, I want to make sure that I'm in the right directory. cd mkdir, cd tmp ls. I want to create a new directory, say docker build ls-l cd docker build. All right, and here's the thing, because I'm lazy, I'm going to use a tool called WinSCP, because I IPADDR, because I wanted to just simply copy and paste my files instead of typing everything, because you don't type in demos. I want to log in as root. I could log in as me, but I just want to simplify this for now. And I will go and look at the directory that I just created, tmp and docker build. Okay, I already have a file named docker file, which is exactly what I showed you. Right? This is exactly what you saw. It's a very simple text file. And by the way, it has to be capital D and no extension. If you look at this, it says file, doesn't have any extension. Right? Docker file. That's how it's supposed to be. Although, you could use some techniques in order to use files like this or this. But let's stick with Docker file. Okay, I want to upload that to here, drag and drop, and let's build sudo docker images. Perfect. I need the CentOS image to build that custom Docker image. Okay, so let's see. Docker build. There we are. And run. And here's what this thing is going to do. And I'm going to explain, oops, keep forgetting sudo. This is what this guy is going to do. It will reach out. Did I? No, this is not the one. Give me a quick second because I think I copied the wrong image or the wrong Docker file. Yes, wrong Docker file. I need this one. Okay. A wrong Docker file. There we are. Yes. There. What this does is, and I want to walk you through what's going on here. It's reading every single line in the Docker file. First, it reads the from statement, and then right here it ran. It's step number 17. It ran the curl command. Part of that is pulling. Now let me open this. Open with Notepad. Label is just label, right? So it read this. It didn't have to pull the CentOS 7.6.1810 image because I already have it in my local repository. It had to pull this file, the repo file, store it in the local repository as well, and then install SQL Server. And that's why you see this. Now it's installing SQL Server, it's installing all of the dependencies. And keep in mind, this is the exact thing that you're going to be doing if you want to install SQL Server on Linux, not inside a container, but on just any Linux environment. Okay, it's installing all of those dependencies, and now we're on step 8 so far. Okay, every single one of those steps will form an image, and this image will become the foundation of the next image. Remember what I mentioned earlier? It's just like building Lego bricks. First is the CentOS Linux image, then the repo file, then the SQL Server on Linux, then the installation, and then this. Now we're on step number 9, 10, 11, 12, 13, and voila, we're done. Okay. Sudo docker images, my new image, SQL 2017 CentOS, and it was created 11 seconds ago, and it's merely 1.32, way smaller than the ones from Microsoft. My one from Microsoft is around 1.5, 1.6. We can use this now. Sudo docker ps-a. Okay, I got hello world. Let's do this. Instead of using this, let's use our newly built image. And because it's a newly built image, I want to use the new tag. Run this image. Done. Done. I just ran a new SQL Server on Linux image based on the custom image that I just created. Let's connect to this thing. IP-ADDR 227. Let's connect to this machine. 227. And I want to make sure that I type the password correctly. Now, I want you to see the difference between that and this one. You can see the difference right there, right off the bat. This one's 14.0.3048. This one's 3335.7. That in itself shows the difference. And let's rerun the exact same query. This one was from the SQL Server on Linux image that was available from Microsoft. This one is from the one that we just built. It's same name, but it's running Server 2017 RTMC21 on Linux, CentOS Linux 7. I just built my own custom SQL Server on image using a Docker file, right? And this is, again, the power of what you can do with creating custom images, deploying SQL Server quick and fast, and deploying it in production, okay? I do have a series of articles that I wrote on MS SQL Tips last year that walks you through the entire process that I did with other stuff, like using Docker volumes to store SQL Server database on them, with SQL Server on Windows containers. I don't like using SQL Server on Windows containers because, for one, they're too big, right? But like I said, I've written an entire series, a 6-part series, 1, 2, 3, 4, 5, 6-part series article on MS SQL Tips that outlines everything that I just showed you today, okay? To wrap this all up, containers and DevOps is simply containers is just one tool. There are so many tools, and containers are a great tool to make DevOps easier, but keep in mind, DevOps is not just a tool. It's a culture, it's a principle, it's a philosophy. It's a process built with tools and people, okay? Deploying SQL Server on containers is just one way of making DevOps easier. And if you're a SQL Server DBA, or if you're responsible for managing SQL Server databases, you got to get on board, because every developer is now getting their hands on this. Sooner or later, they will take over your job unless you start taking control. I've been privileged enough to write an entire book on this topic. It's available on Amazon. Yes, they made it available last month. This is one of the great things that came out of this lockdown thing. It was supposed to be out in September, but because everybody's locked up at home, we managed to expedite the whole publication process. Now it's available on Amazon. In fact, the minute that I got home, I saw my printed copy of the book in my doorstep. So here it is. I'm opening up the floor for questions. If you have any questions, feel free to use the chat window. I'm more than happy to respond to those questions. There's my contact information.
Yeah, Edwin, there's a question from Kevin on the chat. How does licenses work on containers? Do you need to pay for licensing when you pull a container locally?
That is a great question that I try to avoid as much as I can, but the real answer of every licensing person that you ask would have a different response. But here's the rule of thumb. The licensing for SQL Server on containers is the same as licensing SQL Server on bare metal, on physical machine, on virtual machine. What do I mean by that? If you want to dedicate an entire Docker host, if you want to dedicate that simply for SQL Server, you have to license the entire physical machine. Or in my case, my virtual machine running containers, you have to license it on a per core basis so you can run as many containers as you want. Now, if you want to mix and match, meaning you want to run other containers on top of that Docker host, then you may want to provide additional parameters on the container, meaning the number of virtual CPUs, because keep in mind, you're paying SQL Server licenses based on virtual CPUs. So you have to tweak your containers because, again, by default, it will take as many CPU cores and as much RAM as it can, which means, well, you got to be ready for licensing if you want to use up all the available CPU cores on your Docker host.
All right, cool. So far, that's the only question on the chat. There's another one. We have a question from DataMess. Since the containers self-terminate once its processes are over, how is the container defined to know when its processes are over? Would SQL Server need to be shut down?
That is a really great question. Now, keep in mind, if you look at, let me go back a couple of slides back here, the last item in my Docker file, because this is exactly how Microsoft created their own SQL Server on SQL Server on Linux images. The last command, the last line in my Docker file is the SQL Server.exe. Well, I don't want to say exe, but it is the SQL Server binary. It's the one that runs the SQL Server database engine. If there was another command after this, and this wasn't the SQL Server process, the container will terminate, and you would have to tweak the image in order for it to continue to run without terminating. Okay. In contrast, when you remember if you remember the hello world container, the minute that it completes its task, it terminates because there's nothing else to keep it running. Okay. The SQL Server executable in Windows, when you run it, it continues to run. Just don't make the mistake of terminating it, because when you terminate it, it will terminate the container. It's just like shutting down SQL Server. And in the container world, when you shut down the process that's running, or in this case, the app, if you terminate the app, it will terminate the container. Okay. There have been cases that I've worked with in the past where somebody created a custom image and they can't figure out why it's terminating. For one, well, if SQL Server isn't the last command, or if the executable is not the last command in the Docker file, then it will just terminate. Okay, so even in applications, again, I'm going outside of the scope of our conversation. Imagine that you're running a PHP or a Java application. You want to make sure that the container, the Docker file that you're writing, will have as the last command running either the web server or the app in an indefinite loop, so that the container doesn't terminate.
All right, I think that answers the question. Yeah, so if you guys have any more questions, you saw the how you can reach Edwin, so you can reach him through those channels. And yeah, that's all for tonight. If you just joined us for the second session, just a reminder, next week we're gonna have Arrow for Power BI data DAX 101, and we're gonna have Uwe Rieken from Germany for database scope settings. Thank you very much, Edwin.
Thank you very much. Have a wonderful evening, and I'll see you all sometime in the future. Thank you.
Yeah. All right. Sure. Good night, everyone. Keep safe.